Download this code from codegive.com, link in the description below. Dynamic data masking from SQL Server to Power BI, a comprehensive tutorial. This tutorial will guide you through implementing dynamic data masking, DDM, in SQL Server and subsequently connecting masked data to Power BI. We'll cover the concepts, setup, implementation, and considerations, including code examples and best practices. Understanding dynamic data masking, DDM. Dynamic data masking is a SQL Server feature that limits sensitive data exposure by masking it to non-privileged users. It works at the database engine level, meaning applications and users access the masked data without modifications to their code. Key benefits of DDM **** reduced exposure of sensitive data * prevents unauthorized access to sensitive data like credit card numbers, email addresses, and personal information. Simplified security compliance * helps comply with data privacy regulations like GDPR, ccpa, and hipaa by controlling data visibility. Minimal application changes * doesn't require alterations to existing applications, making implementation less disruptive. Centralized data masking * masks data at the source, database, ensuring consistent masking across all connected applications. Important considerations ***. DDM is not encryption *** DDM is for presentation purposes. The underlying data remains intact. Someone with sufficient database privileges can bypass the masking and see the original data. For stronger security, consider data encryption. Performance impact * DDM can introduce a small performance overhead, as the database engine needs to apply the masking rules. This overhead is generally minimal but should be tested in a production-like environment. Data types * DDM supports masking for various data types, but not all. Verify compatibility with your data. Common data types supported include varchar, nvarchar, char, int, bgint, date, and datetime. User privileges * define a clear strategy for user roles and permissions. Some users will require access to the unmasked data, example auditors, HR. 2. DDM masking functions. SQL Server provides several built-in masking functions. Default, * masks the entire value based on the data type. String types, example varchar, become XXXX or similar. Numeric types, example int, become 0. Date types, example datetime, become 01/01/1900. Email, * masks the email address by revealing the first letter and adding xxx@xxx.com. Example, axxx@xxx.com. Partial, prefix padding suffix, * reveals a specific prefix and suffix, while padding the masked portion with a custom character. Prefix, the number of characters to show at the beginning. Padding, optional. The character to use for masking. Defaults to X. Suffix, the number of characters to show at the end. Random, start _range end _range, * masks numeric values with a random number within the specified range. Applies only to numeric types. 3. Implementation steps. 1. SQL Server setup ****. Connect to your SQL Server instance ** use SQL Server Management Studio, SSMS, or a similar tool. Select or create a database * choose an existing database or create a new one for this tutorial. Code example, create a sample database and table. 2. Apply dynamic data masking ***. Use the alter table statement with the add masked with clause to apply masking rules. Code example, applying masking rules. *email, masked with the email, function. Will show the first letter and mask the rest. *phone number, masked using partial, 2, x2. Shows the first 2 digits, the last 2 digits and masks the middle with X characters. *credit card number, masked using partial, 4, x4. Shows the first 4 and last 4 digits, masking the rest. 3. Creating a user with limited permissions ***. Create a SQL Server login and user with limited access to the database. This user will be used to access the data from Power BI. Grant only select permissions. Code example, creating a limited user. Important * replace password 123 with a strong, secure password. 4. Testing the masking ***. Verify that the masking is working as expected. Code example, testing the masking. You should see the data masked according to the rules you defined. If you execute the same query as the administrator, or a user with unmasked permission, you will see the unmasked data. 5. Granting unmasked permission, optional. If certain users, example auditors, need to see the unmasked data, grant them the unmasked permission. Code example, granting unmasked permission. 4. Connecting to Power BI. 1. Open Power BI Desktop * launch Power BI Desktop. 2. Get data from SQL Server ***. Click Get Data on the Home ribbon. Select SQL Server Database and click Connect. Enter the SQL Server instance name and database name, masking demo. Crucially, specify the masked user credentials ***. Choose database under data connectivity mode. Expand advanced options. Enter the masked user login name and password. Click OK. 3. Select the table ***. In the navigator window, select the employees table. Click Transform Data to open the Power Query Editor, recommended for verifying the masked data, or load to load the data directly. 4. Verify masked data in Power Query Editor, recommended. In the Power Query Editor, review the data in the employees table. You should see the masked values for email, phone number, and credit card number, exactly as masked in SQL Server. This confirms that Power BI is receiving the masked data. 5. Load the data ***. Click Close and apply to load the data into the Power BI model. 6. Create visualizations ***. Build Power BI visuals using the loaded data. Users will only see the masked data, ensuring data privacy. V. Code example, removing data masking, reverting to original values. If you need to remove the masking for some reason, example for maintenance or testing, you can use the following code. 6. Best practices and security considerations. Principle of least privilege * grant only the necessary permissions to each user. Use the unmasked permission sparingly and only to users who absolutely require access to the unmasked data. Regular audits periodically review user permissions and data masking rules to ensure they are appropriate and effective. Data sensitivity classification identify and classify sensitive data within your database. This will help you prioritize which columns need to be masked. Testing thoroughly test the masking implementation to ensure it meets your security requirements and doesn't negatively impact application functionality. Documentation document the masking rules, user permissions, and the overall implementation strategy. This will make it easier to maintain and troubleshoot the system. Data encryption at rest and in transit. Combine DDM with data encryption at rest, example transparent data encryption, TDE, and in transit, example TLS, for a more robust security posture. DDM protects data presentation, while encryption protects the data itself. Power BI security. Remember that Power BI also has its own security features. Use row-level security, RLS, in Power BI to further restrict access to data based on user roles or attributes, even after the data is loaded into the Power BI model. This is especially important if you are using direct query, as the data remains in SQL Server and RLS rules are enforced at the SQL Server level. 7. Troubleshooting. Invalid data type error. Ensure that the data type of the column you're trying to mask is compatible with the masking function you're using. The random function only works with numeric data types. Masking not applied. Verify that the user connecting to the database is the limited user you created and that the masking rules are correctly defined. Double-check the execute as statement and the grant select permission. Performance issues. Monitor SQL Server performance after implementing DDM. If you experience performance degradation, consider optimizing your queries and indexes. The impact of DDM is usually minimal but can be more noticeable on large tables or complex queries. Power BI errors. Authentication issues. Double-check the SQL Server login credentials in Power BI. Make sure the user is enabled and has the correct permissions. Data loading errors. Review the Power Query Editor for any data transformation errors. These errors can occur if the data types in Power BI don't match the data types in SQL Server. 8. Advanced scenarios. Conditional masking. Implement masking based on specific conditions, example mask data only for users in a specific region or department. This typically involves using a custom function in SQL Server that checks the user's context and applies the appropriate masking rule. This is a more complex implementation that requires careful planning and testing. Integrating with Azure Active Directory, Azure AD. Use Azure AD for authentication and authorization to SQL Server. This allows you to manage user identities and permissions centrally. Dynamic masking based on time. Implement masking that changes based on the time of day or day of the week. This could be useful for hiding data during off-peak hours. By following this comprehensive tutorial, you can effectively implement dynamic data masking in SQL Server and securely connect to Power BI, protecting sensitive data and simplifying compliance with data privacy regulations. Remember to tailor the implementation to your specific requirements and conduct thorough testing before deploying to a production environment.